So I mentioned that with standard deviation, one of the downsides is it's not resistant to outliers or skewed data. So what do you do in those situations? We know for measure of center, instead of mean, we can use the median. But what about measures of spread, like how spread out the data is? Well, one of the things we typically use in that case is quartiles. Now, quartiles are actually very similar to what we had been using when we talked about percentiles. Quartiles are percentiles. So percentile, remember, is the number that's above a certain percent of the data. So first quartile, quarter, is above 25% of the data. So the first quartile is the same as the 25th percentile. The median is above half of the data, so the median is the 50th percentile. Third quartile is above 3/4 of the data, or 75%, so it's the 75th percentile. We don't typically say this, you could say that the minimum value is the 0th percentile, and the maximum value is the 100th percentile. So how do we calculate these and look at them for a set of data? The minimum is just MIN, and I'm just going to type out cell references here. So I'm getting all the data from B10 down to B56 and going across. Okay. Um, let's see, anything interesting there? Well, to me, the fact that out of two entire classes of statistics students, the lowest that anyone rated their home life is a 65 is surprising to me. I would have expected there to be some, at least, that were very low. Um, and close to parents even. The fact that the lowest, the minimum, is a 40, that's also surprising. All these zeros and ones, they don't tell us too much because it could just be that there's one or two people in the class that have very low on that particular value, or it could be that there's a lot. We don't really know. But what these higher minimums tell me is that even in the worst case scenario among these two classes, the home life is above the middle, above 50, the middle of the scale. Okay, what about quartile? Quartile, we could do percentile because there might be one for quartile. But percentile, we'll do the data here. Whoops. Yeah, E56, right? And then the percentile is 0.25. That gives us our quartile there. Are there surprises here? We can see, for example, the low, read the Bible. So 25% of these two classes had pretty much almost never read the Bible, either never or almost never. So the fact that that number is continuing to stay low, even at the 25th percentile, says there's a pretty big chunk, as opposed to, say, the extroverted, which the minimum scale was a 0. Someone felt themselves extremely shy and introverted. But once we get to the first quartile now, we're almost at the center of the scale. So that is a bit different than this situation. Okay, median. We could do percentile, but I'm just going to do Ooh, I like this, suggested based on the data. So Google Sheets is all over this. That's great. I'm going to go ahead and move that across. And let's see. Anything interesting? Again, now I had seen that the means were really high on some of these values, but still, the fact that the median, I guess this would surprise me a little bit, that over half, or at least half of the class, median means the score of 93 is greater than or equal to half the class. So it also means that half the class is 93 or greater, which seems like a pretty good chunk of the class that believed in loving God there. Third quartile, let me just actually paste this formula here. I'm going to cut it to the clipboard because really the only thing different here is we're going 0.75 now for the third quartile. And then maximum, I don't know, let's just have fun here. I don't know what'll happen if we put 1.00, like the 100th. Okay. Um, it allows us to do that. Uh, I typically, so I think that would be legitimate. I typically do the max. It is 98, so it did work. Um, but these give us our maximum values. Again, we can kind of flip what we did with the minimum and see here. If we see 100, that doesn't mean much because it means there's just at least one person in the class who put 100, which maybe the rest of the class is lower. But here, read the Bible, 75. That tells us out of two classes of students, the highest out of those two classes was a 75. That tells us we don't have really any avid Bible readers out of two classes of students. And at a Christian college, I mean, maybe that says something about, is it really Christian college, or what does that actually mean in reality? That would be a good discussion here based on the data. And then finally, the interquartile, this is really the equivalent of the standard deviation. So this is going to factor in both the 75%, which is going to not really worry about the top 25% or any outliers, and then the 25th percentile, that first quartile, which kind of filters out the lowest one that could have some extreme low values. So these are your more balanced measures of spread, and we combine it all in an interquartile range. So we just see how far apart these two things are, and we can just do a quick subtraction for this. So we interpret this very similar to how we did the standard deviation. In fact, I'm going to go ahead and color code this too. I'm going to do a conditional formatting. Kind of excited. I've never actually run the interquartile range for these data, even though it really would be a smart idea since some of this data is skewed. Let's take a look at how that compares. So we can see, first of all, that the places that were dark red with standard deviation also tended to be red here. Um, we do see that the O in student loans, it was the highest here, but here it's even more clearly the highest. So which is good because financial data, I would almost always default to a resistant measure of spread, something that's not going to be easily influenced by outliers, which would be this right here, right? Because this is factoring out the top 25% and bottom 25% of the data. So it's going to be a lot more resistant to the skewed data you could get with financial data. So to me, it shows me that the difference in student debt is actually a lot stronger than I would have been able to see from the standard deviation. Now, to be clear, I'm not comparing these exact numbers, like the 25 to the 18. What I'm comparing is how this standard deviation compares to the rest of the standard deviations, and versus how this IQR compares to the other IQRs. Overall, I mean, it really does follow the same pattern, right? This is the lowest and second lowest IQR. This is the lowest standard deviation and second lowest. So for the most part, it looks like the standard deviation would have given us a pretty decent measure of spread, even though some of the data was skewed and had some outliers. So one final thing that this could be used for is if you are running data or conducting some kind of study, and you're a little nervous about the skew of the data, if you're finding out that, okay, the IQR is really matching up with the standard deviation, that would be good justification for going ahead with the standard deviation, because the standard deviation allows you to do many more statistical tests, things that are called parametric tests, than the IQR does. So by seeing that they're virtually the same relative, like the categories are, we can see which ones are spread out very smallly or cluster around the mean or median, and which ones are really spread out. Yeah, so that is the IQR as well as the quarters. By the way, these five together are called the five number summary. And you really have the quartiles, the lowest, the first, the middle, the three quarters, and the max. Those together are the 5-number summary. And the visual of that is a box plot, which looks something like, here's actually side by side 2 box plots, but you can see how they're labeled here. You can do them sideways or vertically, it doesn't matter. Here we're looking at commute times. So what we can see here is even though the median time for both groups is about 20 minutes, the median commute time, we can see that the New York data is really spread out a lot more. There are some people probably living in New Jersey or other bordering states who are driving over an hour to work, whereas that's not happening so much in North Carolina outside of whatever city they're looking at right there. So the 5-number summary here isn't just showing us the measure of center, it is showing us the spread as well. And that's a useful visualization of the 5-number summary is the box.